and you can compare the front of the machine, which is straight, and the rod, right? And you just take the belt and you pop it into the end clip, and then you move it out of the way so it's easy to reach, and you pop it into the second clip.
Okay.
Right? And for those of you on that side of the room, you've got two clips here and here. Right? You can do it with your fingers, right? Yeah. It just, it's just a little bit easier to stop it twisting the pliers, but it depends on whether you're a left or right hander. And now I'm working on the wrong side. Yeah.
That's enough.
It just pops it back in.
Specific to?
Yeah, it pops back in. That's the easy fix.
It just finds it's little happy place and then you pop it back in.
I kind of need to be standing
I have a set square so I can tell that it's square.
You don't have to be that. It wants to be square, right? So that when it's bent and you pull out the belt, it almost always pops straight back into position.
Yeah.
And then you put the belt straight back in. But like I say, if your cousin missed it, you put it at the front, go, oh, look, you're square. If you're standing at the back, you can see this piece touching the front piece. And if it's not, there's a gap, right? Yeah. So this is what we call a 3-minute fix. You know, it's a bit harder than a 30-second fix. And it's usually easier if you're facing the right side, but I'm working from the back and my fingers don't know how to do that. Right? So that is, here's my stat sheet. That is a big number. It's like 20% of the problems fixed right there. This is the biggest thing. So what is extruder calibration? See this little drop-down sensor that comes down? It's going to come down here in a minute, right? First of all, it needs to come straight down, not on an angle. If it goes on an angle, they probably pull it apart, put it back together.
Yeah, I've seen
and the cables are in the way. Yeah, and when you
try and level it.
And when you open it, you discover they've somebody at some point has pulled it apart. Now the cable's in the way and it can't move. And that's never going to work. So you guys can see, and I can't, but I'm hoping that's straight down. Right? And it was, and now it's gone back up.
It flicked back up, yeah.
What's happening is you've got a measurement stored in the machine that is the difference between the tip of that sensor and the tip of the nozzle. If you change the hot end, you need to change it because it's going to be microscopically different, right? Every manufacturing line is going to have a bit of movement. If it's been packed wrong and the bed's been compacted, all of a sudden the distance is going to be different, right?
In the early 3D printers, we used to put a sheet of paper in.
It's exactly what we're about to do.
Oh, okay.
So, you guys should be running my class. Right, okay, so what you do is you start the extruder calibration, which we just did. I'm too short for this job. You open the door and you put a piece of paper. You wait till it got to this point. It's magic paper, you know, recycled. And you pop it under the nozzle, right? Now, the thing people do wrong is they push on the piece of paper, which pushes on the bed that's on springs, right? So you got to tell them, only touch the paper. And then you hit minus on your tippy toes, and it's usually
that's like offsetting
about 1.1, so we'll just speed that game up.
Oh, that's how you're doing that.
Z-axis, yeah.
And then,
He's eyeballing that.
okay,
When it stops moving.
when it just starts to grab the paper, I did. You were one of my best students ever. All right, so this one's a bit tight. No, it's about right because I'm doing it at the wrong angle. But you can feel that, and feel free to come along. If it's too tight, you're ripping the paper, right? If it's too loose, you don't have the grab. What I didn't do, and I should have done, is check that there was no filament off the nozzle before I started, right? But we'll pretend that it was
when
good.
we do this at home, they normally recommend that you preheat the printer while you're doing.
If there's they're just trying to make sure there's no filament tipping out the bottom. You look at it and you go, yeah, my nozzle's clean, go, right? You look at it and you go, there's filament hanging out of the nozzle, unload first, right? But it's that just grabby, and you can hear it. It just grabs, it just scraping on the paper. That's the magic point, right? And then, you get up really tall. You hit okay, and then, what does that one say? Finish, yeah, finish is a good word, right? And then you hit finish, right? And it's going to lower it. That is part one. That is not the end of the game. This is part one. So, then...
You should say end of part one as a button.
It really should. And it should go straight into the next routine, and I've spoken to them about doing that, right? Yeah. And then you go into level. Level is the pivot of the bed. Z offset is how high it's going to go, right? When you do the level routine, it tells you to screw all the screws. Yeah, ignore that. Yeah. Right?
We've
Just
told them
keep moving on.
Just keep screwing it.
Yeah, just don't do that, right? And you jump on. Now, until you've done Z offset plus level plus turn machine on and off, it has not saved that data, right? So you've got to do it in that order. Z offset, level routine, on and off.
Why on and off for it to save?
It transfers it from its
Flash memory.
current memory, if you like, to its here.
Okay.
Right?
So the on off.
So at that point, it does that. Yeah, you know how long it took me to work that one out.
Saves it.
Right?
Can you just go back? So it saves it with the on and off cycle. What does
Yeah,
that
so
mean?
we're going to just jump in one more time, right? And just not do it all. But you go Tools, Settings, down arrow, you've got Extruder Calibration. You jump in there, you're going to measure that Z offset, right? Then
It's in Flash at the moment.
it's done that. And then we go back to the main menu and we run level. We ignore the message it's about to tell us to screw the screws, and you go round. If it gets to, and some of you will have had this where it just constantly says it's verifying,
Yes.
it's a fraction out. Screw it in one or other direction. You got a 50-50 chance of getting that micro difference to have it right? And then you'll be right. So, 50% of the time you will have guessed that it needed to go up. And 50% of the time you would have guessed it went down, and then it'll tell you to make it go up. But it was just at the trigger point on the end stop, right? So again, it's going to ask us that question. We're going to ignore it any second now. And then we're going to power it off and on from the button, and then that stuff will be saved, right? They are, in a nutshell, the problems. Right there, more than 80% of our problems. Right? Just these little things. Don't put stuff on the bed. Do your Z offset.
So
do
you
your
have
level.
to power it on and off to get it to
By the
save
front.
it.
not the
At
back.
some point. So you could start printing and then turn it off when you're done.
Yeah.
But if you, I don't know, just turned it off at the power point
Which
and didn't
people
let it do
They
that
normally
power
flick the kill
routine.
switch. Some,
Yeah.
I've seen them do it.
Yeah.
And so consequently it didn't go through that routine, which is why we tell people to do it at this point.
So you have to do it. So you have to do it by the front
So
button.
yeah, and that makes it do that power down properly versus I just killed your
Right,
electricity.
let's kill it.
right?
Settings wide.
Yeah. So again, we say, yeah, we screwed it. I definitely did. Yeah, I definitely did it. I did. Right? And then it goes to the first point and it drops its little sensor and you adjust it. I'm pretty sure you guys are all okay with listening to a sound and working out if it's level. So we're going to assume that. And I went, you are level, congratulations. And you go, I am so good. And then you power it off and you say, yes, you want it to power off. And you power it back on and da-da, right? Have a glue stick. Banish it to the arts and craft department and never let it come near the 3D printer, please.
Note to self.
This stuff is awesome. It
is
sprays
super
very,
glue.
very thin and it just recoats the bed. Does two things. First of all, if it's not quite level, it'll still stick, right? Which gets us to the next group of problems we'll talk about in a minute. And the other one is it recoats the surface of the bed so it's like it was new. So they don't have to change the tape as
Some of those surfaces we've seen look like a battlefield.
Oh, yeah, and a terrain. Like there, right? And of course, if you've got a terrain and you try and run a Z offset, the sensor's touching the terrain, not the
and they had
bed.
you glue
Right?
layers
Yeah,
about
yeah.
that thick, just piled up and up.
And the other one that's going on is people are spraying other glues onto the bed and they get into the bearings and damage them. And that does cause some really serious problems. So it's water-based.
I just said that.
And
Would you take the bed obviously out, spray it away?
I screwed that. Anatomy, right? Anatomy of a 3D printer. Nozzle screws into heater block screws into barrel. Barrel has a heat sink on it in this edition, right? In other machines and older 3D printers, the heat sink used to sit in front of it with a fan blowing on it, and it was a separate item. And nowadays they go around the barrel a bit more like this. There's still a fan blowing on it, but that's what you're looking at. Big thick white cables, they're your source of heat. Blue cable is measuring the heat, right? If you ever get to a school and you see the temperatures are jumping in an irrational way, it is telling you when you turn on the machine that it is 100 degrees in your room. And you sit there and go, I was hot, but I'm not that hot, right? Then your thermocoupler is lying, and thus your thermocoupler is damaged but not broken. If I cut it with a pair of scissors, the machine knows that it can't complete the circuit. But if it's damaged, been crimped, slightly broken, they had a print fail they didn't tell you about, and this bit's sort of semi-broken but hasn't come off, you get weird and unusual things out of the machine because it doesn't really know what's going on, right? I'm not teaching you all the complications of tech support, but I do want to say to you, certain numbers are actually error messages, so pay attention to that number. If you turn on a machine and it's telling you, for example, it's 1024, it doesn't think it's 1024, it is telling us an error code. So if you are getting freaky stuff going on, just pay attention to what's on the screen. If you don't have time to write it, take a photo. Come on, you've all got cameras in your pockets.
Had one where it wouldn't heat.
Yeah, you cut a piece of filament and you touch it. If it's telling you it's not hot and you touch it and it melts, then the thermocoupler is lying because it really is hot. If you touch it and it really is cold, your thermocoupler is telling you the truth and something's happened to the heater cartridge, right? It's pretty simple from that perspective. Really, really rare to have a broken heater cartridge. And I always put a tray in when I'm working on machines, and if you're really like out and you've got nothing, sit the hood in and it catches all the screws beautifully, right? But you undo your 3 screws and then you can see your extruder. And after this, my learned friend over here and I am going to film the proper full swap of a hot end. And this will give you this in more detail. So this is the abridged version. But don't be afraid, please, to A, follow any instructions we give you, and B, to take this cover off before you necessarily contact us, because a lot of the filament jams are solved by just taking this off, because you'll see it. There is a bit of double-sided tape here. We've told the factory to stop doing it because then when you lift it off, you can rip it off, right?
Surprisingly easy. Bowser talking through it on the phone before I spoke.
Okay, so
You get the broken bit just in there.
yep. So number 1, you'll get one just in there. Number 2, you'll have a little piece just inside the motor, and this is your motor, right? And see, if I do a line here, the screws are in the corner of the motor, so the screw. It's very difficult to do up. This one I can't do upside down. Right, see this little hole here? That's your first motor screw, just there. Your second motor screw is level with the motor.
Don't pull those motor screws all the way
Yeah, I
out.
was about to do that. And we put that in the instructions. Do not pull them all the way out. So you loosen them and you hold your motor and go, yeah, I've loosened them enough, I can now pull my motor backwards, right? Okay, so when you take the motor off, and I'm not going to do it because, time and stuff, but you'd end up with that in your hand, right? And what you might see is a bit of filament here or here, and the one that gets people, and every time they will have been printing with black filament, and it's a black mount, and you won't see it. So get a smaller Allen key, turn the sucker upside down and poke it in the hole, and I depress this, and one of the things we talk about in this fact sheet is cutting white filament in a piece, and you put it in the top, make sure it comes all the way out the bottom, and you know it's actually clear because there'll be a little millimetre of black filament in that hole that you won't see. So you just poke it all the way through, right? Almost all the filament jams are in this area, and they're almost always a thin tail, and you might need a pair of tweezers to catch it, and you pull it out, and then you're sorted, right? So that's your top bit. The next bit is sometimes you have one bit just poking out the top here. So, oh no, I didn't take the motor off. I just did that in my imagination. And then you can heat it up. So you tell it to load with the motor. You can...
It's on.
Yeah, I'm turning it off before I disconnect. Always turn it off before you disconnect an electrical cable. You can unplug this, and then you can take this and just sit it off to the side, and then you can see what's going on. And if you've got a bit of filament coming out of the top of the hot end, just under the here, so it would be coming off that heat sink we prepared earlier, there, right? So you'd have a little bit of filament poking out here, right? Yeah. You tell it to run load without the motor on, and you let it heat up, and then you grab that and you pull it up, right? And you did that, right? Yeah. And 90% of the time, that'll be fine. There is a rare and delightful situation where they have cooked it for a long time, and when you engulf an extruder, this is one of the things that can happen. And so now you've got carbon all solid in here, right? And you've got Buckleys and none. And at that point, the filament has literally cooked to the point that it is black carbon now, right? And so it doesn't matter what you do, it's a solid and it's fused.
Is that the stuff like when you drill it, because I had to drill one, and when you drill it, is that the stuff that builds up on the inside of the...
Yeah.
Okay.
Please don't ever drill it again.
It was under, Greg gave me instructions.
I'll tell Greg off later.
Yeah,
Right.
you threw him under the bus.
This
there.
is yeah, you did, and he is in so much trouble. I have told him off before. It's okay, he's used to me doing that. The problem is that we coat these in a really tough material, right? And when you drill them, you can remove and scratch the coating. And then what you create, and the other thing you can create is if you drill even slightly on an angle, you create a triangle divot that filament fills into, and then it'll block later on. So it's a very short-term solution to drill them out. That is different from having a 4mm drill bit and using it as a poking tool to clear the nozzle. All of the stem share kits in principle, in practice, may need that fixed in their toolkit, have a nozzle clearing tool, which is a 3D printed piece that you can put your finger in so you don't burn it, and you can poke the little spike up the hole.
Must be really fun.
Because-
These
Looking at me so bad. If they press up against the nozzle with it, they're not going to burn their fingers. And it sits on your finger,
So if it's a lower
right, like
extruder
this,
issue, though,
and you can poke into the nozzle to just clear it if it's blocked just at the tip. Right? And it comes with spares so that you just pull that out and you put a new one in. Right? So that's to clear the nozzle versus the bow handle tool, which is to clear from the top, and this is to clear from the bottom. It's quite unusual that you would have this problem, but if you load white filament and you see brown and black coming out, you've got somebody before you came along, cooked that extruder and didn't sell you. So, yeah, and so we suggest you run load and then you depress the lever and you push it, so you're pushing through not completely melted filament, and it will grab all the carbon and help push it through, but also only push for a moment so you know it's coming out, and then pull it up, and you'll pull up all the carbon rather than trying to push it through the 0.4 hole, right?
Sorry, so you're saying
So-
almost bond it to the
Exactly, and you'll do
filament.
that 3 or 4 times. So you'll run load, you'll push it just enough that you can see it coming out the bottom, and then you'll press the button and you'll pull it up, and you'll see all this brown and black stuff, and you'll cut it and you'll do it again until it actually comes out white and clean, and then you know you've pulled all that up. Exactly, right?